Good day, everyone. My name is Mr. Garth Reed, and I'm a student ambassador in the University of Technology, Jamaica. I'm also a mathematics teacher in training in the School of Mathematics and Statistics. All right, today we'll be going through curve sketching in Module 3 of Calculus 1 of the CAPE Pure Mathematics Unit 1 syllabus. All right, so here we have our question. The equation of a curve is given by f of x is equal to x minus 1 over x squared minus 2x plus 5. Part 1, find all the stationary points of f of x. Part 2, classify each stationary point. Part 3, evaluate the limit of f of x as x approaches positive infinity and the limit of f of x as x approaches negative infinity. Part 4, determine the x and y intercepts. And finally, sketch the graph of f of x. All right? So what you should know about stationary points is that they exist when dy by dx is equal to 0. That is when the gradient function is equal to 0. All right? So we are required to differentiate f of x here. Now, the rule that we'll be using for f of x is the quotient rule. All right? We have it in the form of u over v, so we know that we're going to use the quotient rule. So I have the quotient rule here to my right, which says d by dx of u over v is equal to v du by dx minus u dv by dx all over v squared, all right? And you should also remember the power rule, which we will be using as well. So when you differentiate x to the power of n with respect to x, you get n times x to the n minus 1, where n is a member of a set of real numbers, all right? So let us get into the question. So we have part 1, which says find all the stationary points of f of x. So the first thing that we need to do is to differentiate, right? We need to differentiate f of x. So let me just write the function down here. So it says that f of x is equal to x minus 1 over x squared minus 2x plus 5. All right? That's what our function f of x is. Good. Now we want to differentiate f of x using the quotient rule. So f prime of x is going to be equal to, that's v, which is the denominator. So that's x squared minus 2x plus 5, following the quotient rule. That's v times du by dx. U is the term in the numerator, which is x minus 1. So that's d by dx of u, which is x minus 1, minus u, which is x minus 1, right, multiplied by the derivative of the denominator, which is x squared minus 2x plus 5. All right? And remember now that we have to put that over the denominator squared, which would be x squared minus 2x plus 5 all squared. Excellent. So now let us simplify our work in here. So I still have the x squared minus 2x plus 5 in brackets. Now, using the power rule, if you differentiate x minus 1 with respect to x, you will get 1, right? Which is the coefficient of x there. Minus, I still have my x minus 1 on the outside. Now I'm differentiating x squared minus 2x plus 5 with respect to x using the power rule. So when you differentiate x squared, you get 2x. When you differentiate negative 2, you get a negative 2x. When you differentiate negative 2x, sorry, you get a negative 2. And when you differentiate 5, you get 0. So that's done. And we have to put that now over the denominator squared, right? Which would be x squared minus 2x plus 5 all squared. Good. Now, what I'm going to do is to simplify the numerator. Now, when you multiply this quadratic expression by 1, you get x squared minus 2x plus 5. I will keep the negative and I will multiply x minus 1 by 2x minus 2. All right, so that's x times 2x, which is 2x squared, x times negative 2, which is negative 2x, negative 1 times negative 2x, that's negative 2x, and negative 1 times negative 2, which is a positive 2. All right. And remember now that that is over the denominator squared, which is x squared minus 2x plus 5 all squared. Good. Now, remember that the negative will have to be distributed in the bracket for each term. All right? So that's x squared minus 2x plus 5 minus 2x squared plus 2x plus 2x, and the last term, negative 2. All right? And we're dividing that by the denominator squared. That's x squared minus 2x plus 5 all squared. Good. Now, let me just change the ink here. Immediately, you can see that some terms cancel out, right? This negative 2x can cancel with this positive 2x. All right? So what we now have is x squared minus 2x squared, which is a negative x squared, right? We have a positive 2x remaining, and we have 5 minus 2, all right, which you know is 3. And we are dividing that by x squared minus 2x plus 5. Now we can't simplify any further, all right? So this is now f prime of x. Good. So now we have the derivative, so we can now use it to find our stationary points. All right. So remember now that stationary points, let me write it here, stationary points exist when the gradient function, which is f prime of x, is equal to 0. All right? So f prime of x equal to 0 implies that this function here on the right-hand side is equal to 0. So that's negative x squared plus 2x plus 3, right? And we are dividing that by x squared minus 2x plus 5 squared equal to 0. All right? So if we should multiply both sides of this equation by the denominators, right, you will get negative x squared plus 2x plus 3 equal to 0. Okay? Now, what I'm going to do is just get rid of the negative sign that is here in front of the x squared. So I'm going to divide through by a negative 1, which will give me a positive x squared minus 2x minus 3 equal to 0. All right? Good. Now, what we're going to do is to factorize this quadratic on the left-hand side. All right, so when you factorize, you are supposed to get x minus 3 multiplied by x plus 1, and that is equal to 0, right? So remember now that the product, just to refresh your memory, the product is going to be the coefficient of the x squared term, which is 1, multiplied by the negative 3, which is the constant at the end, equals negative 3. And you're supposed to get a sum of negative 2, which is the coefficient of x, right? So remember now that you need two numbers. When you multiply them, you get negative 3, and when you add them, you get negative 2. And those two numbers are negative 3 and positive 1, right? Now, remember now that when the coefficient of the x squared term is 1, you can just write down the factors, all right? If the coefficient is not 1, you will therefore have to split the middle term, right? So you need to split the term in the middle into 2 terms. All right, good. So now let us solve this equation. We have x minus 3 times x plus 1 equal to 0, right? So that means either x minus 3 is equal to 0, which implies that x is equal to 3, or x plus 1 is equal to 0, which implies that x is equal to negative 1. All right? So now we have our x values. Let us now find the corresponding y values. So when x is equal to positive 3, right, f of 3 is going to be equal to 3 minus 1, right, using the function that was given in the question. All right, that's the function that we're using. That's 3 minus 1 over 3 squared minus 2 times 3 plus 5. And if you should put this value in the calculator, you will get 1 over 4. All right. Let us now find the corresponding y value for x is equal to negative 1. So when x is equal to negative 1, f of negative 1 is going to be negative 1 minus 1. All right. And we're now going to divide that by negative 1 squared minus 2 times negative 1 plus 5. All right, if you should put that in the calculator, you will get a negative 1 over 4. Good. So therefore, what can we say? We now have the x values and we have the corresponding y values. So we can now say that the stationary points are 3, 1 over 4, and negative 1, negative 1 over 4. All right, so those are our stationary points. Good. So we have now completed the first part of the question, which says find all the stationary points of f of x. Now the second part of the question now says classify each stationary point. What do we mean by that? All right, so let me write it here. Part 2, solution. All right, so when we're classifying the point, what we're really saying is that determine if the point is a local maximum point, a local minimum point, or a point of inflection, right? Now, there are different ways you can go about testing this, right? To test if it is a local min, local max, or a point of inflection. Now, you have the second derivative test, where you calculate the second derivative and substitute the x values inside, and based on the signs that you get, whether it's positive or negative, right, or 0, we can determine what the nature is, right? Now, you also have the gradient test, where we use the first derivative and we get as close to the point as possible, right? We investigate the point by getting as close as we can to the point from the left and from the right, and based on the signs, whether it's positive or negative, right, we can determine the nature of the point. Now, remember, let me just scroll back up. Remember that this is what we got for our first derivative, right? The negative x squared plus 2x plus 3 over x squared minus 2x plus 5 all squared. Now, using the quotient rule and that again in order to get the second derivative will be a bit tedious. So what I'm going to do is to use the gradient test. All right, so I'm not going to use the second derivative test. I will use the gradient test, where I'm using the first derivative only. All right, so let me just write it back here. or f prime of x was equal to negative x squared plus 2x plus 3, and we are dividing that by an x squared minus 2x plus 5 all squared. All right? Now, let's look at the gradient test now. So I'm going to create a table basically. So I'm going to have x here, the sine of dy by dx. All right? Oh, I have f prime, so I'm going to use that notation. The sine of f prime of x. Okay. So what am I going to do here? I'm going to have the first x value, which I calculated, 3. All right. I'm going to have 3 there. Sorry. Just trying to draw the table, and then we will discuss. All right, so I'm going to have the negative 1 right here. All right. Good. Now, what I'm going to do is to go as close as I can to the point 3, right, from the left and from the right. So I'm going to put the 1 from the left right here, and I'm going to put the 1 from the right here. All right, so this one is going to be the left of negative 1. This is going to be the right of negative 1. Okay, so the point that I'm going to choose that is to the left of negative 1 is going to be 2.9. And from the right, I'm going to choose 3.1. All right, I could get closer, but those are the points that I'm going to choose. All right, when you're investigating a point in mathematics, you need to get as close to the point as you possibly can, right? You don't want to stray away from the point because other things might start happening and might affect your solution, all right? So if you should plug in 2.9 into the first derivative here, right, you are going to get a positive value. All right, and we know that x is equal to 3 is a stationary point. So when we plug in the 3 into the gradient function here, f prime of x, we're going to get 0. And if you plug in 3.1 into the gradient function, you will get a negative value. Good. Now, the point that I'm going to choose that is to the left of negative 1 is going to be negative 1.1. And the point to the right that I'm going to choose is a negative 0.9. When you plug in negative 1.1 into the gradient function, you will get a negative value. We know that negative 1 is a stationary point. So you plug in negative 1 into the gradient function, you will get 0. If you substitute negative 0.9 into the gradient function, you will get a positive value. All right? So let us just discuss what is happening here. Let's discuss it. Now, if you plug in 2.9, you're going to get a positive gradient. All right? So we know that positive gradient is something like this. Okay. Now, if you plug in 3, x equals 3, you get 0. So we know that we're going to have a horizontal line there, right? The tangent line is horizontal, and for 3.1, we get a negative gradient, which is something like this, all right? Now, what this tells us is that at the point x is equal to 3, we have a local maximum, right? We use the term local or relative maximum point, all right? Now, you should know that we don't use the term maximum point, right? Because this is not the absolute or the global max, right? We use the term local or relative maximum point. So if you should use the term maximum point, you are absolutely incorrect. Okay, now when we look at negative 1.1, we get a negative gradient, which is something like this, right? So we have a tangent line like that, and at x equal -1, we get a tangent line being 0. It's a horizontal line, and at -0.9, we have a positive gradient, all right? Now what this tells us is that at the point x is equal to -1, we have a local minimum point, all right? So let me just write a statement here now. So based on the table above, right, we can see that 3, 1/4, this stationary point is a local maximum, all right? So that point is a local max. And what about the other one? The other one is -1, -1/4. All right, so this stationary point is a local minimum point. Good. So we have now successfully answered I believe it's the second part, yes, the second part of the question, which says classify each stationary point. Now we're at the third part, which says evaluate the limit of f of x as x approaches positive infinity and the limit of f of x as x approaches negative infinity. So this is part 3, solution. All right. So let me calculate the limit as x approaches positive infinity first. That is going to be equal to the limit x approaches positive infinity of x minus 1 divided by x squared minus 2x plus 5, right? Now, whenever the denominator has a higher degree than the numerator, the answer is going to be 0, all right? The answer will be 0. So what we're really doing is to just focus on the terms, the higher degree term in the numerator and the denominator, right? So for the numerator, you can see that the highest degree term is this, right? This x term here. And this is the term that we're focusing on in the denominator, all right? Now, you can clearly see that the degree, let me write it here, the degree of x minus 1 equals 1. When we say the degree, we just mean the highest power of x, all right? That's 1. And the degree of x squared minus 2x plus 5. So the highest power of x there is 2, right? So clearly, you can see that the denominator has a higher degree than the numerator, right? So once that is the case, you will have 0 as the answer. All right. And if we should calculate the limit as x approaches negative infinity of f of x, that's the limit x approaches negative infinity of x minus 1, and we are dividing that by x squared minus 2x plus 5. All right. If you calculate this limit, you will also get 0. All right. So the limit as x approaches negative infinity is 0, and the limit as x approaches positive infinity is also 0. All right. Now we have finally answered part 3. It is now our turn to answer part 4, which is determine the x and y intercepts, right? The intercept. So this is now going to be part 4 solution. Good. So when x is equal to 0, what is going to be f of 0? So you substitute 0 into the function, right? F of x, you will get 0 minus 1. And we are dividing that by 0 squared minus 2 times 0 plus 5. So basically, you will get negative 1 over 5. All right? So that's one of the intercept. The other one now is when f of x is equal to 0. So when f of x is equal to 0, we have x minus 1, and we are dividing that by x squared minus 2x plus 5, right? So that's equal to 0. So if we should multiply both sides by the denominator, it implies that x is equal to 1, right? Because when you multiply both sides by the denominator, you will get x minus 1 equals 0, which implies that x is equal to 1. All right, good. So we are finished with that question now. So we have now determined the x and y intercept. And the last part of the question now says, sketch the graph of f of x. All right, sketch the graph of f of x, which is part 5. So this is part 5 solution. Okay. All right, so I'm just gonna draw the x and y axes. Okay, good. So this is going to be my x-axis. This is going to be my y-axis. And I have 0 right here, right? So first of all, let us sketch the stationary points first, right? We're gonna locate our stationary points first. So let me put 3 right here, all right? And here, somewhere here, is going to be 1 over 4. All right, so our stationary point is going to be somewhere here. All right, and negative 1 is over to the left here, right? And we have negative, we're going to have the negative 1 over 4 right there. And our stationary point is somewhere there. All right. So let me just darken it a bit. All right. So we have now located our stationary points. All right. Let us now put in the intercepts that we calculated. So the intercept was when x is equal to 1, right? So I'm going to put 1 somewhere here. When x is equal to 1, y is 0. That's somewhere right there. Right. And the other intercept was when x is equal to 0, y is equal to negative 1 over 5. So somewhere right here. All right? Good. So I believe that we have all our points now. Let us now sketch this curve. So remember, at x is equal to negative 1, we have a local minimum. So we're going to have something like this. All right? So this is a rough sketch. So we're going through these 2 points, and we have a local maximum here. All right. Good. Now we want to know how the curve behaves at the extreme ends, right? That is the reason why we had calculated the limit of f of x as x approaches positive infinity and the limit of f of x as x approaches negative infinity. Both were 0, right? That was our answer. So what that means is that the curve actually approaches 0 here, and the curve approaches 0 here. Sorry. Let me correct that. Right. So what we're saying is that the x-axis, right? The x-axis is going to be a horizontal asymptote, right? So here we have f of x, which is equal to x minus 1 over x squared minus 2x plus 5. All right, that is our solution. Yes, so this is our graph, right? We had calculated the limit of f of x as x approaches negative infinity and as x approaches positive infinity, and the answer was 0. So that is the reason why our graph, right? That is the reason why our graph is approaching 0 here and here. All right? Now, that is our solution, right? That is the graph of f of x, which is equal to x minus 1 over x squared minus 2x plus 5. All right, so we have now answered all the questions. My name is Mr. Garth Reed, Student Ambassador for the University of Technology, Jamaica, and I'm a mathematics educator in training in the School of Mathematics and Statistics. I thank you for joining.